So in this video, we are looking at solving absolute value equations. Now the equations we're going to be solving are going to be in the form of the absolute value of ax plus b, where a and b are just constants, x is our variable, equals to k. Now there's going to be a couple of results that we're going to be getting based on the definition of an absolute value. Now, if our value k is less than 0, the equation is going to have no solutions. Now think back to our definitions of the absolute value. If we take the absolute value of something, our answer will always be positive. So there's going to be no solution to this where we're going to get an answer out where k is less than 0. Next one, if k equals to 0, the equation is going to have one solution. We're going to look at how this works in a little bit. And if k is greater than 0, the equation has two solutions, which we can find by solving two kind of mini equations. One is where the positive case, ax plus b equals to positive k, and the negative case, where ax plus b equals to negative k. And we're going to show that these are going to be, in fact, solutions by subbing them back into the equation and checking that they work. Now, we're going to solve the first three here. Now, the first one, it says 3x plus 6, the absolute value of that, equals to negative 21. We already know that there are no solutions as our value of, on the other side, as our k value is less than 0. So there's going to be no value of x that's going to make this true. Next one, we see that 3x plus 6, the absolute value of that equals to 0. Now, we're going to just look at this using this same lens of making two mini equations. Now, for 0, whether we do positive 0 or negative 0, we're going to get the same solution. It's very similar to the discriminant in our quadratic equations. The same logic applies. Whether I set this thing to equal positive 0 or negative 0, we're going to get the same solution twice. So we're only going to have one unique solution. So we're just going to set our 3x plus 6 to equal 0. We only have to set it to equal 0 because plus 0 and minus 0 are the same thing, or they'll give us the same answer. And if we move the 6 over to the other side and divide through by 3, we're going to get that x equals to negative 2. Now for the next one over here, now we can look at the two solutions that we get. Now to do this, we're going to set up two mini equations. We're going to take the positive case, 3x plus 6 equals positive 21, or 3x plus 6 equals negative 21. So we are going to just solve these systematically and get a solution. So here 3x is going to equal to 15, and x is going to equal 5. Now let's just check this solution by substituting it back in. 3 times 5 gives us 15, plus 6, that's 21. The absolute value of 21 gives us 21. So that solution is correct. We're going to do the next one over here. So we're going to subtract 6 from both sides. We get 3x, I should say. Let's just fix that up a bit. So 3x equals to negative 27. And x equals to minus 9. Let's just check this one by substituting it back in. Putting minus 9 in place of x, 3 times minus 9 gives us minus 27, plus 6 gives us minus 21. Remember, it's got the same magnitude. This value gives us 21 in our absolute value, which when we take the absolute value of 21, we get 21. When we substitute this one in, we get the absolute value of negative 21, which when you take the absolute value of a negative number, it gives you the positive answer. So these two are our two solutions for part C. Just a couple more to practice. Now, first one says that x, absolute value of x minus 2 equals 3. We're going to set up our two smaller equations here. So our first one is the positive case, x minus 2 equals positive 3, and then x minus 2 equals negative 3. So these are just simple one-step equations. Our first solution is x equals to 5. Our next solution is x equals minus 1. Now you can pause the video and confirm that these are correct, but These are going to be our two solutions, and you're going to see that when you substitute it back into the original equation. Now, last one, we have the absolute value of 7 minus a quarter x equals to 3. We're going to set up our two equations. So one is that 7 minus a quarter x equals to positive 3, or 7 minus a quarter x equals to negative 3. Solving this first one, we get minus a quarter x equals to minus 4. So x equals to 16 when we divide both sides by negative a quarter. And next one is minus 1 over 4, x equals minus 10. And then when we divide both sides by negative a quarter, we get that x equals to 40. So once again, we can verify that dot point in our two equations in example 2. Our k value was greater than 0. 3 is greater than 0, and 3 is greater than 0. So in both of these cases, we expected two solutions. When we went through and solved it, we got our two solutions. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.